This is Kunal Gautam, and in today's class we are going to discuss a new topic, that is a concept of frequency in continuous time and discrete time. Okay, so first of all, we must have to understand what is the continuous time signal. Continuous time signal is analog signal where it is vary with respect to the time. That is continuously vary. So, as for example, this is the graph here we discuss in the time domain, and that is also for the amplitude. Okay. So it is visualized here that the signal is continuously vary with respect to the time. So when the signal was complete signal, the time period will decide like that, it's a T. Okay. So first of all, when we have to transmit in the discrete time signal, then it has to be passes through the sampler and the quantizer. Okay. So because our DSP processor only understand the language of digital signal, so we can't directly process the analog signal or the continuous time signal. So first of all, we must have to convert the continuous time signal into the discrete time signal, because the DSP processor only understand the discrete time signal, only understand the digital signal. So what is the process to convert? Basically, it has to be passes through the sampler. Sampler, okay, quantizer. But we don't have to go in depth with the study of the quantizer. Okay, when it passes through the sampler, then it samples the signal. It samples the continuous signal into the discrete time signal. Okay, now this is all the continuous signal, and continuous signal is sampled, right? So we are going to sampling here. So it is very like that. Okay. 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 Now, what is basically each sample having some spacing. So we define here the spacing is denoted by the TS. So it is called sampling interval. TS is what? TS is sampling interval. Okay, we are providing sample at the time domain, maybe also in the amplitude also. Amplitude. So when the sampling provided at the time domain, okay, by the help of the sampler, spacing is due to the sampling process. So it is called sampler. And the shifting or the providing a actual shape or spacing in the amplitude. So it is the process of the quantizer. So we don't have to go in the depth of the quantizer, because we have to only describe the concept of the frequency. So by using the sampler, we can easily describe the sampling frequency and sampling interval. Okay. So what is the TS? TS is equal to 1 upon Fs. And Fs is what? Fs is equal to the sampling frequency, and we can say that the sampling interval or sampling interval. TS is equal to what? Sampling interval, and Fs is equal to the sampling frequency. Okay. So now we are going to draw a flow chart. Okay. As for example, this is our continuous time signal. Okay, and you have to convert it into the discrete time signal. So signal has to be passes through the sampler. A sampler, what is the work of sampler? It converts the continuous to discrete converter. And lastly, we get the signal in the form of the discrete time signal. Okay. As for example, we are taking here in the mathematical form xt xt is the continuous time signal, and now we are going to providing a sample. A sampler basically a techniques which sample the continuous time signal. Okay, so t is equal to n of t. Now we get the discrete time signal that is in the form of x of nt. Okay, in a graphical way, this is our continuous time signal. Okay, where the horizontal axis represent the time domain, and the vertical axis represents our y-axis amplitude. Okay, for one complete signal that is ended here, we define a interval like that, or t is a interval of the signal. मतलब after the t time period, the signal is repeating in a continuous manner, so it is called also a periodic in the nature, continuous time signal. Okay, it passes through the sampler. What is the work of the sampler? It basically converts the continuous time signal into discrete time signal. Okay, so what we get, the result is like that. Sampler. Okay, t, and that is the xt, and what is the, this is the part of the x of nt sampled. Okay, we don't have to go through the quantizer because we don't need to, in the term of the define the frequency in the continuous time signal or discrete time, we don't require the concept of the quantizer. Okay, so that is basically a flow chart to how to convert a continuous time signal into the discrete time. So by mathematical derivations, we are going to describe it, the relation between the continuous time and the discrete time frequency. So first of all, we are taking an analog signal. Consider an analog signal. Okay, so x of t is equal to, that is the standard form, a standard equation of the analog signal, a cos 2 pi ft. And okay, we are taking some shift of angle, so here we are putting that theta. Okay, in the term of the angular frequency, that is our standard equation. Okay, in the term of the angular frequency, we can write that xt is equal to a cos 2 pi f is equal to, what is the value of omega? Omega is equal to 2 pi f, so we can write that omega t plus theta. Now here a is equal to what? A is basically a amplitude of the signal. A is amplitude of continuous time signal. Okay, ct, in the short form we are writing here, a ct is a continuous time signal. Okay, f is your frequency of continuous time signal. Omega is equal to what? Omega is equal to angular frequency. Omega is angular frequency. Okay, and theta is equal to angle. Theta is equal to, we can say, phase angle. Okay, so that is our analog signal. Now we have to convert it in the discrete time signal. So now put t is equal to what? T is equal to n and t. So this is our equation 1. Then when put t is equal to n of t, then it will convert xt into the x of n. So that is the standard equation of the what? Discrete time signal. So xn is equal to a cos. Now put the value of t in the place of t is equal to a cos 2 pi f, and what is the value of t? T is equal to nt. So putting this value in the equation 1. So 2 pi f and n into t plus theta. So that is the standard equation of the continuous time signal. Xt is equal to a cos 2 pi ft plus theta, and that is the standard equation of the discrete time signal. Xn is equal to a cos 2 pi, just we are putting here, t is equal to what? N into capital T, 2 pi f n t plus theta. Equation 2. Here t is equal to what? T is equal to 1 upon fs. T is equal to 1 by fs, where t is equal to, that is called as a sampling interval. Sampling interval, and fs is equal to sampling frequency. Sampling frequency. Now we can write in equation 2, x of n is equal to a cos 2 pi f n upon fs plus theta. Okay, so we can write that equation 3. Okay, and what is the standard equation of the discrete time signal? So x of n is equal to a cos 2 pi fn plus theta. So it is the discrete time signal, a standard equation of the discrete time signal. Okay, so we can write also it in the form of xn is equal to a cos omega n, plus theta. Okay, now the frequency is equal to, we can write the frequency, capital small f is equal to f upon fs, and the angular frequency we can denote the angular frequency like that in the symbol of ohm. Okay, is equal to 2 pi f. So we can put the value of ohm is equal to 2 pi f in equation 3. So at the place of the 2 pi f, you can write the xn is equal to a cos 2 pi f, and the value of the 2 pi f is equal to ohm. So a cos ohm n upon fs plus theta, and that is the equation of the equation value 5. It is a discrete time signal. So this is the part of the equation. Basically we write omega, that is in the form of ohm. It is our continuous time, angular frequency. So don't be confused with the value of omega. Omega is equal to discrete time angular frequency. Okay, so